Bismillahirrahmanirrahim. Dear students, topic atmospheric pressure. What is atmospheric pressure? Prove it with the experiment. Atmospheric pressure, Earth is surrounded by a cover of air called the atmosphere. Earth is surrounded by the cover of air called the atmosphere. It extended to a few hundred kilometers above the sea levels. Just a certain sea creature lives at the bottom of the sea. So we live in the ocean of the air. As a mixture of the gases, the density of the air does not remain same. It change. It is not uniform. It does not change same. It change continuously. It decreases when we go upward from sea level to upward. Now give the two example. One example is this. This girl, please see this picture. This girl is making the soap bubbles. When she blow through the soap solution, bubble will be formed. The bubble will be changed into circle form. Why it happened? It is happened due to the atmospheric pressure exerted on equal direction. Now this is the example of the balloon. Now we fill the air in the balloon. Balloon began to expand. When we saw that we fill more air, it will be changed into circle form. How it take place? It take place that atmospheric pressure exerted equally in all the direction. Now we explain with the experiment. This is the tin can. Take a empty tin can, fill it with water. It is also consists of the lid. When we take water in it, after that we put it on the flame. When water began to change into steam, we remove away from the flame, closed it with the lid and take it inside the water tap. When water fall on it, it began to collapse. Why it collapsed? It collapsed due to atmospheric pressure exerted equally in all the direction. एटमॉस्फेरिक प्रेशर ज़मीन के इर्द गिर्द हवा का एक गिलाफ है जिसने उसे घेर रखा है, उसे एटमॉस्फेयर या कुरावाई कहते हैं। ये 400 किलोमीटर तक फैला हुआ है। उसमें जैसे हम देखते हैं समंदर की तह में समुद्री मखलूक रहती है, इस तरह हम हवा के एक गिलाफ में रहते हैं। हवा गैसेस के एक मिक्सचर है। हवा की डेंसिटी एक जैसी नहीं होती है। बुलंदी की तरफ चलते जाएंगे हवा की डेंसिटी कम होती जाती है। इसको साबित करने के लिए दो मिसालें हैं। एक लड़की साबुन के सोल्यूशन में फूंक मारती है, बुलबुले गोल शक्ल इख्तियार होकर आगे मुंतकिल होते जाते हैं। ऐसा एटमॉस्फेरिक प्रेशर की वजह से हुआ है। एक गुब्बारा ले, उसमें हवा भरें, अब देखो गुब्बारा गोल शक्ल इख्तियार कर जाएगा। ऐसा क्यों हुआ है कि इस पर एटमॉस्फेरिक प्रेशर बराबर मिकदार में असरअंदाज हो रहा है। इसको साबित करने के लिए एक तजर्बा करते हैं। एक टीन का डब्बा लें, ढकने समेत हो, उसमें थोड़ा पानी लेकर उसे शोले के ऊपर रखें। जब पानी भाप में बदलना शुरू हो जाए, इसके ढकने को बंद कर दें और पानी के नल के नीचे ले जाकर पानी उसके ऊपर डालें। डब्बा अंदर की तरफ पिचक जाएगा। ऐसा क्यों हुआ है? एटमॉस्फेरिक प्रेशर की वजह से हुआ है कि वह चारों तरफ से बराबर मिकदार में इस पर असर अंदाज होता है। मुख्तसर सवालात। एटमॉस्फेयर किसे कहते हैं? व्हाट इज़ एटमॉस्फेयर? 156 पर इसका आंसर मौजूद है। 156 पर ये इसका आंसर पहले प्ले। ज़मीन को हवा के गिलाफ ने घेर रखा है जिसे एटमॉस्फेयर कहते हैं। हमारी ज़मीन को हवा के गिलाफ ने घेर रखा है, जिसे हवा के गिलाफ ने घेर रखा है, उस हवा के गिलाफ को एटमॉस्फेयर कहते हैं। अर्थ इज सराउंडेड बाय द ओशन ऑफ द एयर विच इज़ कॉल्ड द एटमॉस्फेयर। फर्स्ट लाइन। सेकेंड क्वेश्चन इसका है, एटमॉस्फेरिक प्रेशर कैसे असरअंदाज होता है? हाउ द एटमॉस्फेरिक प्रेशर अफेक्टेड। 156 पर इसका आंसर मौजूद है। एटमॉस्फेरिक प्रेशर हर सिमत में बराबर मिकदार में अमल करता है, ये इसका आंसर है। एटमॉस्फेरिक प्रेशर हर सिमत में असरअंदाज होता है। एटमॉस्फेरिक प्रेशर अफेक्टेड इक्वली इन ऑल द डायरेक्शन। ये शॉर्ट क्वेश्चन थे, इनको याद करना है। और एक मूवी भेज रहा हूँ आपको, वीडियो भेज रहा हूँ। वीडियो से इसके एटमॉस्फेरिक प्रेशर बिल्कुल क्लियर हो जाएगा। वीडियो से आपको समझ लग जाएगी बेटा। अल्लाह हाफ़िज़।
Envelope of air around us is what we call atmosphere. Does air also exert pressure on objects on the earth? In our previous video, we studied that the liquid exerts pressure in all directions. For example, here we have the water in a beaker. Due to gravity, this water is pulled down towards the earth. If we divide this water into different layers, then each layer is being pulled down by the earth. Due to this pull, water exerts downward pressure and this pressure is uneven throughout. That is, the bottom layer experiences more pressure than the top layer. This is because the weight of water above the bottom layer is more and the pressure decreases as we go upwards. In fact, we saw that the water exerts pressure in all directions and not only in the downward direction. One more thing that we studied about the liquid pressure is that at any point in a liquid, the pressure is the same in all directions. That is, if I take any point here in this water, the pressure exerted by water here is the same in all the directions. Air also behaves in the same way. Just like water, air is also being pulled down by the Earth's gravitational force. This force applies pressure on the air in the downward direction. The pressure exerted by air is called air pressure or atmospheric pressure. Did you know that the atmosphere is divided into different layers? The atmosphere is divided into 5 layers, namely the troposphere, stratosphere, mesosphere, thermosphere and exosphere. The pressure in the troposphere, which is the bottommost layer, is higher than the pressure in the layers above it. And I'm sure you can guess the reason why. This is because the weight of the air above the troposphere is greater than the weight of the air above, say, the stratosphere. The air pressure also acts in every direction and not only in the downward direction. And finally, just like the pressure in liquids, the air pressure at a particular height above the Earth's surface is same in all directions. That is, if I take these 2 points at the same distance above the Earth's surface, then the air at this point will exert an equal pressure in all the directions, just like the air at this point. Let's look at an interesting graph now. A graph which represents pressure at a particular altitude. The graph also represents how the pressure varies from layer to layer. The troposphere layer is closest to the surface of the Earth and the pressure in this layer goes up to 100,000 Pascal, where Pascals, represented by PA, is the SI unit of pressure. This is massive pressure. This pressure pushes and pulls the object on the surface of the Earth. For example, if I take a table with the upper surface of 1 by 1 meter, the pressure exerted by the air on the table in the downward direction is greater than 1 lakh pascals. This is equivalent to 10 cars being put on this table. Yes, 10 cars. I know what you must be thinking. Why doesn't the surface collapse under this huge pressure? How does it handle such massive pressure acting down on it? A little while ago, we said that the pressure exerted at points above the Earth's surface is equal in all directions. So the pressure at every point on the table is the same in all the directions. That is, if downward pressure is pushing the table surface with a great force, then the upward pressure is also pushing it in the upward direction with the same force. Both the forces are balanced and the table does not collapse. As I said, pressure is not only acting in these 2 directions, it is acting on the surface in all the directions. Pressures acting in opposite directions cancel each other out. Here is one cool experiment that you can also perform at home. Take a plastic bottle filled with water. Take a cardboard paper and place it on the open end of the bottle like this. Hold this paper with your hand so that it does not move from its position and invert the bottle. Now let go of the paper. What did you see? The cardboard paper sticks to the surface. Why is it held to the surface? It is held to the surface because of the air pressure that is pushing the paper in the upward direction. The upward air pressure is sufficient to counter the downward push exerted by the water. Now make few holes in the bottle at its base. What happens now? Why did the paper fall off? Did the upward pressure on it stop acting or did it reduce in the value? No, it didn't. The upward pressure on it by the air remains the same, but the downward pressure increased in its value. When we made holes in the bottle, we allowed air to flow inside it from the top. The air from the top started exerting pressure on the water. The combined pressure of water and air from top could easily overcome the pressure exerted by air from the bottom. Hence, there is net force acting on the paper in the downward direction. That is, there is more pressure in the downward direction. That is the